Don't applaud yet. You haven't heard me speak. Welcome, everybody. Thanks for coming out on a snowy Denver day. That was nice of you to arrange that for me. I live out on the coast of Oregon, and we don't get snow, so it was a special treat to see just a little bit out there. I appreciate you all trekking through that, and hopefully the local snow plows weren't even necessary where you live. I have a couple of topics for you. I'm going to go bang, 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 and share views of some of the different technology solution areas we have. We've heard some higher level views of what Cloudera does, how people are thinking about transforming their organization, how governments are moving to use data, use analytics, use machine learning, use insights in new ways. I'm going to talk a little bit more specifically about some of those use cases and how our technology plays in those environments. But I'm kind of curious, just a level set for me, how many of you have ever actually worked with Hadoop specifically? Show of hands? Well, only a couple people. So this is a newer technology you're exploring still. That's good. Hadoop's actually been around for over 10 years. I was at a conference a couple of years ago and bumped into my old college friend who's on the fencing team with me. It's a nerdy industry. It's OK. We could be on fencing teams. And I ran into him. I said, hey, Mike, what are you doing at this conference? He said, oh, I wrote this thing called Hadoop as a grad student project when I was at University of Washington. So I have a very personal connection to the origins of Hadoop. I also have an observation on how this industry is changing. I'm very new to Cloudera. I spent the last 3 years as an industry analyst, so looking at big data technologies, looking at analytics, how they operate. And I got to pick my dream job at my dream company. So despite some of the articles you might see out there now, oh, Hadoop is dead, we're moving on to the next technology, it's all about machine learning, there's really value in what we've built as a company. And I'm really excited to kind of share with you how it sets the stage for managing more data, doing more things with it, getting multidisciplinary analytics, and evolving your services in the future. And the last thing I want to say, just by way of intro, is I don't work directly for government or with government very regularly. In the past I have, but I am a citizen, so I use your services a lot. I'm not a citizen data scientist either, but I'm a citizen. So I really want to help you be successful in what you're doing so that we get more efficient government, we get better services, we get more insights on how to deploy the resources we have. I think that's what we're all really here about, and I'm going to show you some ways we can help you do that. So without further ado, let me launch in. I skipped right over my intro slide. That's all right, I'll skip that one. Protecting data. So this is one of the most important things I see we should all be thinking about. Doesn't matter what your role is I have data about me that's personal. I know for a fact that data has also been lost to the wilds many times, and there are cyber criminals and whoever out there who can get access to my data. That bothers me. I'm kind of a weird paranoid guy, and knowing that like my credit card info is out there everywhere I've ever lived, all my social media stuff, that this stuff has been lost time over time again. When I travel, regularly, my credit card gets rejected. Oh, you're in Denver. It must be fraud. We're cutting you off, which is a little awkward at dinner because I only carry one credit card and not a lot of cash. So ways that you can get smarter about how you manage the data that comes through your business is really critical. And if you look at these questions here and think about what data you have in your environments, it might vary. Maybe you have information on citizens in your territory and how they're using your services. Maybe you have billing information about them. You may have information that is relevant to how those services are delivered. I met a gentleman in the back who said he worked with a water district. So now as we're putting more and more of these key utilities online, they're subject to attack. How do we manage those services appropriately, keep them safe? You might have to meet compliance and regulations. There are regulations that come out of our government all the time, that come out of industry. There are regulations that even come out of Europe. And you go, well, wait, we're Americans. We're here in America. This is about as American city as you can get. What do I care about what they say in Europe? But how many people have heard of the European Union General Data Protection Regulation, or GDPR? Hey, that's good. This is one of the better rooms I've seen. If you're not familiar with it, the EU has decided that anybody who holds data or processes data or moves data or manipulates data on European citizens is subject to a new set of scrutiny. And one of those things is the right to be forgotten. I can say, hey, I'm not your customer anymore, get rid of all my stuff. That can be hard to do. It has lots of implications, and let me tell you, even if you think I'm here in Colorado, this doesn't affect me. If you have European citizens who you are tracking because they're coming through your airport, or they're living here locally, but they're still citizens and they're registered, hopefully they're registered to vote and you're all voting today. But that aside, we need to be able to manage and meet these regulations, and that's another use of protecting data is compliance with regulations. So a little bit more specific, depending upon what area you're working with the data, what types of data, might be around cybersecurity. We had a nice talk at Cloudera a week ago where we had the local regional field office of the FBI sent an agent to come talk to us about how they were detecting threats. A lot of them were foreign actors, foreign states, and they were looking at a lot at network data as a great way to understand what was happening. Who is communicating with whom is one of the easiest ways to start to spot these things. What's the user data? What are the connections? But looking at how much data passes through networks, public or private, it's ridiculous. And trying to find the outliers, find the ones that are anomalous, find the ones that tell you where to focus your resources. That is extremely hard to do with traditional technologies. There's just too much data. And you might be looking for patterns that combine across different services. Maybe it's just logs from routers, but maybe it has things to do with phone calls. Maybe it has things to do with movement of people. There's lots of different ways to look at that. Fraud, I mentioned fraud being a big security concern for citizens. If you're holding their data, you need to be able to make sure you're protecting that information. It's no good saying, well, I'm not a commercial enterprise, so I don't really care. I know nobody has that attitude. You guys are all engaged. You're all switched on. And then not least, you might be looking again at that compliance, and we might be looking at transactions, HR data, financial data, making sure that everything is by the books and we can prove it. And that becomes extremely hard in a fragmented environment. Most of you probably have different databases for different uses. That means when you have to prove compliance, you need to go through a bunch of different locations and prove it for each individual source. And if that data gets copied over here because somebody wants to do some data science and machine learning on it, still got to be compliant. You might not even know where that's happening. So being able to look at all the uses of data, all the places it lives in the environment, and prove compliance, traditional tools just don't keep up anymore because data has become siloed, because it moves around so freely. That's not a bad thing that it does. It just makes it harder to track. So we have all kinds of different use cases that fit in this area. And I won't go through each one individually, but you can see they span from things like visibility, threat response like the FBI had, threat detection, integration with your security tools, fraud, anti-money laundering compliance, waste abuse, all these types of areas. These are all areas where people are using Cloudera in commercial businesses and in governments in the US and around the world. And they're all ways where our platform is uniquely suited to taking your approach to these and upping your game a little bit. And I'll go through how that works. But part of the challenge here is it's hard to manage. I mentioned just the volumes. There's a nice typo in there in terms of too large, but it should be times 2 at least your past difficulty, maybe many more times. Managing the security as the data gets siloed. Here's my data warehouse. Here's my analytics database. Here's my operational system of record. Managing it in different formats. Now we're looking at, Twitter was mentioned before, that the people who run the snowplows in the Department of Transportation were using Twitter. Well, that's kind of cool. But tracking the data from Twitter, maybe you can learn from that. Hey, we need to send a snowplow over here because a bunch of people are tweeting, where's my snowplow? Maybe not in such nice words. Historic data needs to be deleted, archived, you do need to manage it. And then the scale of this becomes hard. It may not be that an analyst can drive this anymore. One of our big partners and a past large investor in Cloudera, I got to talk to their security operations team. And they say they were processing about 100 billion network transactions per day. They have about 25 security analysts that are looking at that data. 25 people, 100 billion transactions. It's not going to cut it if you do a traditional, let me query this one, let me look that one up. So they're now using machine learning to say, give me the 1,000 most suspicious transactions and let me just have my team drill down on those and do some analytics, some heuristics on it. But to get to SQL queries, you need machine learning first. So that starts a great way to work with it. And the problem is a lot of data scientists work with machine learning on a little file on their laptop. They say, give me a sample of the data. I'll take 2 gigs of data and use that to build a model I'm going to use on 2 petabytes of information live and streaming information. The problem is when you have a subset, just like polling, and we saw in elections, the poll doesn't always predict the results accurately. Unless you go talk to everything, unless you look at every individual case, you might be missing a really important pattern. So being able to look at all data, not a subset, not a sample. And then not least, a lot of people are buying into open source. And open source has had a good role to play in government. It's really driving a lot of government operations. Open source is a good thing. Gives you more visibility, doesn't tie you to one vendor. I'm from Oregon. I think I mentioned that earlier. We implemented a healthcare exchange in Oregon. Absolute debacle. Just totally fell on its face. Lawsuits for years with another vendor who will not be named. But The ability to work with open source provides some confidence that you can fire that vendor if you need to, that it's been tested by other people, that it's not linked to one set of technologies, and that's really important about what we do as well. So Amy brought this up before, but I want to come back to this and be a little bit more specific in what we're doing here. There are a number of core services we can run, and there are different kind of work profiles we see happening in environments. Data science is one of them. Data science is simply using machine learning algorithms, applying math to a lot of data to predict things. Anytime people talk about predictive analytics, it's probably machine learning on the back end. In the past, those people used to be statisticians. Do people know the difference between a statistician and a data scientist? Anyone? About $100,000 a year? So they're renaming themselves, they're reapplying those techniques, but because we now have big data new platforms that can do that with Spark machine learning, with other tools, Python and R, then we can go deeper on that. We have analytics databases. In the past, these were traditionally viewed as data warehouses, data marts, et cetera. How many people here are running a data warehouse? All right, a lot of people. Makes sense. Data warehouse is a very common piece of an environment. But be able to deliver that alongside the data science. So I could do machine learning on data in the data warehouse. Being able to do an operational database, looking at real-time streaming information, being able to react in real time, like those snow plows, like people at the ports that are trying to determine, hey, does this truck go through, or do we need to screen it further? Data engineering, prepping that data from different sources, or tying into other applications you already have. And as Amy said, building this all on a shared data experience. Because the difference is, today those things on top are traditionally silos. This is where I was saying your data gets fragmented and it's harder to manage because it's in one environment for one use case. If we can bring all our data together into a data lake, as was mentioned in the last presentation, then that makes it easier to have one data set that can then be used in different ways across the environment. It makes you a lot more efficient. We're not storing the same data multiple times over. We don't have to worry about compliance multiple times over. To do that, we need a common catalog, one way to view and share that data, provide self-service access to it, one way to do security, one way to do governance, one way to manage workloads, and one way to move the data across the environment. That consistency, that unified approach makes it much more enterprise grade, business grade, government grade, makes it much easier for you to run and manage and much more cost efficient as well. And again, if you have a cloud-first approach, which I know a lot of government groups do now, being able to store that data in object storage on Amazon and Microsoft, the Azure Data Lake service, or run it on premises, or do a mixture of both. We see most people ending up hybrid here, and this is where we want to help support you and have, again, the same data platform, whether it's on-premise or in your choice of cloud. And both Amazon and Microsoft are making big investments in government clouds. That's a good thing. We want to be there with you, but give you a common approach no matter where you're doing it. So I mentioned the steps here. We see analytics no longer as a single discipline. In fact, we see it as multidisciplinary. This is really key to how Cloudera views the world and how most people actually operate. The workflows of manipulating data typically come from go get it from your sources, load it up, whether that's batch or stream of real time, figure out what's in it and how it's defined, how to catalog it, how to label it. Let's ingest that data, let's load it, let's save it. Let's do so cost efficiently because we're going to have much higher, larger, where was I going with that word? I don't know. Much more data, let's say more, and being able to do it. And then process it. Make sure that we can set it up in the right format, do joins, normalize columns, set it up so that we know what's in there. We're combining data sets and using them appropriately. Then we can bring our machine learning, bring the libraries you want to use. Again, we support open source here. We're not going to tell you, here are the 3 machine learning tools we support. Bring your own into our environment. Whether you're going to do machine learning that's unsupervised, meaning here's a data set, go find me a pattern, or supervised. Hey, I've tagged images of all these different things. Now learn what this is and then apply it to new images, for example. And do modeling, because you don't do it once. It's an ongoing circular process here. And not least, being able to, again, then query ad hoc. Go find out what's in there. How can I use it? What is it telling me? Be able to do the SQL searches or use NoSQL type approaches as well. This is the pipeline. And again, all these functions, in our view, should be joined up. It should be one continuous workflow, not working with 5 different proprietary tools from 5 different vendors and trying to link them together, stitch them together manually. So some of the key platform capabilities we have here, scale. This is probably the #1 reason Hadoop got big in the first place, is it's just way more cost efficient. A lot of people said they're running data warehouses. If you're doing a proprietary data warehouse from a traditional vendor, I won't name them, but you know who you are. People often tell me I got $1 million, $10 million a year that I'm spending to support that data warehouse. Hadoop is significantly cheaper because it is on commodity hardware, because it is open source, and just the way it distributes the workload across those environments lets you scale and keep as much data as you need for all time. And so that's really important. If you want to go diagnose what's been happening with my bus lines for the last 10 years, if I don't have data from 10 years, I can't do it. If I'm only keeping 6 weeks worth of data because it's too expensive in my data warehouse, I don't have the ability to look into historical patterns for busing and maintenance, for example. Multiple clouds, that's important to us. I mentioned already, you get to choose your cloud, look at which vendor is doing the best services at the best price, and know that you can be portable between them. Typically, the top ones here are Amazon, Microsoft Azure, and Google. And then being able to do data science, as I already said. Use Spark, use the own tools. You may not be the data scientist in the room. Maybe you are. Anybody a data scientist in the room? Well, you got a couple of them. The rest of you are probably serving data scientists. So how do you make that guy right there more efficient? Because he is an expensive resource, and we want to use his time to the best possible ability. So an example here of protecting network environments is Cisco. I'm sure most of you are running Cisco networks. I know they've been very successful in government, whether federal or state and local. Cisco has a tool called WebEx. Anybody here ever logged into WebEx? Is it annoying when it's slow? All right. We're 20, let me check my clock, 2017 here, and we're still not logging in very quickly into it. What they decided was we're going to fix this, and they are starting to fix this. What they've done is they've improved their ratings by looking at everybody's login experience, connecting network data, platform data, operating system data, browser data, all of that, and try and figure out what are the delays and speed up that login process. They've also identified fraud, people that were using invalid connections, people that weren't paying their bills, issues that were happening with the platform, and they're able to do both those functions, less fraud, better customer services for their citizens, and do it at 1/10 the cost they were doing with traditional environments. And so that's one of the ways that this can be applied to do better services and better safety on their environments. So that was topic 1. And I went through some of the ways that we can provide better security, better compliance, better governance, how SDX feeds into that, but more importantly, how doing it in an open source, commodity, scale-out environment with your choice of tools in your choice of environments helps. Second piece I want to come to is modernization. So for people running data centers, for people running data analytics platforms, we're looking to modernize. We're looking at how do we make the world a little bit easier to use, a little bit different from this is the database technology we had 20 years ago, so we're just going to stick with it. I think that logic is starting to fade. If you actually look at market share, this is a little bit of a tangent, but if you look at share of where the traditional 5 players are in the analytics space, people know who they are, Oracle, IBM, Teradata, those types of companies, pretty much the same companies we've been using for 20 years, they're not gaining share anymore. Because people are shifting to these big data, analytics, machine learning environments, most of the growth now is actually happening around these newer technologies. So how do we modernize your environment so you can take advantage of these new technologies and platforms? And that's kind of the second topic we want to look at. So there's some trends here. Self-service. How many of you have to support user requests for data? Yeah, a lot of people. Is that fun? I mean, it's a job, pays the bills. I can go in and get a request. Okay, I need this data set. I can go find it. Is this the right one? Is it valid? What's its history or lineage? Has that data been manipulated before I hand it to that person? But if we could give people safe self-service access to their own data, it's way easier. Puts you out of the way, lets them go get what they need. If you have the right catalog, the right governance controls, the right security, authentication, authorization, those pieces, then you can enable self-service, and that makes your life easier so you can do more strategic projects rather than just serving data requests. It also makes them more productive. So again, that data scientist, data engineer, business analyst, any knowledge worker can go get what they need. Real times also come in. We're no longer looking at just historical data. What was last month's consumption of social services benefits? We'd like to see how many people came in today to collect and what is their mix or makeup. We might want to adjust our patterns. If today's a voting day and we're discovering that there aren't enough voting stations in this precinct and the backlog is there, how do we adjust? Send resources in time. Hybrid cloud environments I mentioned, converged workloads I've already mentioned, but how do we work with data in more different types of analytics together? We see the highest value use cases come when you combining things, data engineering to support machine learning, to support BI, all together rather than distinct environments. So within this, part of what we see modernizing the environment is getting better data preparation, better ETL. ETL is a very time-consuming, arduous task. It seems to go over and over again. And just when you think you're done, nothing happens. But we need to be able to support ETL as it happens on demand, often transient workloads, to get the data in the right state so we can do analytics against it. We want faster insights. We want to be able to look at more data more quickly. Doing more data but having it take forever does not help us. Being able to get an answer in the moment when you're in that quarterly review meeting and the boss is saying, well, wait, what does this piece look like? And they have another question you hadn't thought to prepare a report for. If you can go get that data in the moment, it makes you way more efficient. And then optimizing those data warehouses you have. They're expensive resources. Just to be clear, I'm not saying to get rid of them. Some have. Most people say, I want to optimize it. I want to make that data warehouse as efficient as possible for the right workload. I don't want to use that resource for ETL. That's a kind of a waste of really expensive box. Let's move the ETL off. I also don't want to use it for ad hoc things. That's not good at ad hoc. It takes a long time to program up new reports and get them to run and tested in a data warehouse. Data warehouse, on the other hand, is good at high concurrency, very complex joins, very complex queries. So how do I figure out what should run in each environment? And this is all part of modernization, is taking what you already have been running for 10, 20 years, but bringing in big data, bringing in modern analytics, and being able to use them side by side. So to do this, some of the things you'll get out of it is better performance. You'll get more flexibility for different data, more use cases, more ad hoc nimbleness than you would with a traditional data warehouse. I'll get more cost-effective scale. I'm not in a rigid environment where I need to buy a whole nother rack for another $1 million a year commitment if I want to grow. I can just add in a few more commodity nodes. And I can get beyond just using SQL. I can use data science. I can use other tools, Spark, R, Python, whatever I want against that information as well. So again, traditionally, these things were put together in one unit where you had your query engine, your storage engine, and your catalog information. Basically, just as we've kind of decomposed the rack of a data warehouse, we've separated the functions here. So we have a query layer that can do the different types of queries and analytics you want. We can do it against different storage environments. And we've made it sort of a logical data warehouse. And yes, we still provide a catalog that can provide what these services are, how the data can be used, and that enables that self-service, as well as enabling some of the lineage, the auditing, the compliance, and governance types of functions too. So we're getting away from the rigid data model. Storage and compute don't need to be side by side, particularly in cloud. And a lot of people ask me, well, wait, if I separate my storage and compute, aren't I going to suffer latency? Aren't things going to slow down a lot? The truth is cloud networks have put in quite a bit of sophisticated network bandwidth, quite a bit of performance capability, so that you can separate them and you don't really take a hit. They absorb that because they want to earn the right to get all your storage in their environment and to then run compute as you need to. And I just want to come a little bit deeper on that point. Separating storage and compute is really cool in these environments because if I had everything in one per unit box where they scaled linear, every unit of storage comprised an equal amount of RAM and CPU, then that gets expensive. But if I can say, hey, I'm going to do a data lake and store all this stuff in the cloud at low cost, and then I'm going to bring compute resources as I need to, that becomes a lot more efficient. I can say, okay, I'm going to do data engineering right now. Give me 10 instances to run against that object storage in the cloud. But I'm only paying for them while I'm using them. And if I can decouple that, then I get a lot more cost efficiency. I can do more than just SQL. Traditional data warehouses really were built around SQL. But being able to provide a side-by-side solution, and a lot of people have done this sort of sidecar approach. You'll see the Oracle Big Data Appliance built on Cloudera. You'll see a Teradata Hadoop appliance built on Cloudera. So being able to expand the range of things you can do against that data, being able to grow as you need to, and being able to work in that cloud elastic environment. These are advantages we're really looking for. So when we separate it out, that's where we get more flexibility, we get more portability, we can even move to different environments. When we go beyond SQL, we get one environment, we're sharing across environments, across workloads. We get more cost-effective scale because we're only paying for what we're actually using, not having a bunch of idle system resources. and we can run in a hybrid environment, and that's really important to most organizations. You may put some of your workloads in cloud, some of them may always remain in your data center, so how do you bridge that gap? And you may go with Microsoft now. Microsoft Gov's doing well. You might decide Amazon's got a better story in 2 years. How do you preserve choice for your environment? And if you get that data platform as sort of a shim in there, then you can run it anywhere you want, manage it with the same tools. You don't need to completely retrain on new systems, new platforms, et cetera. So again, some of the things you might be doing here, ETL data preparation, that's transient. It wants to be cloud native. It needs to be able to be isolated so it doesn't slow down. My quarterly reporting, my big batch jobs. But then I also get elastic scale. I can run different workloads side by side. They won't bother each other. And I can be cloud native or local. This is really where we're going with this story. So a little bit repetitive there, but I think you're starting to see some of the benefits that come through by taking a different approach than a traditional data warehouse. And this is kind of a bigger picture of how that fits together. What I really wanted to get to here, by skipping ahead just a little bit, is trying to decide, how do we decide what runs where? How do we figure out, is this a good candidate for big data? If it's in the data warehouse, I know it works right now. It might be suboptimal and expensive, but I know it generally works for those queries. I don't know, how many databases do I have? How many tables? How many users? How many applications? How can I look through that and decide what's a good candidate? And this is where Cloudera actually has technology that can do that work for you. And we call this part of our Navigator optimizer solution. It goes through and looks at all the queries you're running and says, this one's really complex. Keep that on the data warehouse. This one's really simple, and by the way, it's being run a ton, and it's using a lot of that data warehouse resource, but could easily be done on commodity hardware. So it will look at those environments and choose, what should you migrate? What's going to have the biggest impact? What's going to be the least risk? There is a risk question here. If I move this, and it's a critical government service based on this report, is that a problem? I don't know. Let's find out. So our tool will look through them and understand which ones are well suited to running in our environment, and how we'll use SQL on Hadoop to deliver that same capability more effectively. So this is kind of the process we tend to follow through there. I won't go through all the details, but looking at the use cases, the objectives, finding what you can do, testing it out, looking at the plan, figuring out what the impact is. Is this going to make things faster or just cheaper? Ideally, both. Let's figure out how much effort it is to move, which ones we should do first, how much capacity we're going to need. Let's actually do the movement. Let's look at the risk. Let's look at the steps to get there, implement, test, and validate. And then let's continue to tune. And that's an important step, is it isn't just, I'm going to dump that to Hadoop. Hadoop can be my ETL engine. Hadoop can do this basic query for me. But finding out, how do I continuously get more from my environment? That's part of our approach here and part of our step. Partly technology driven, as I mentioned, partly services driven. We have some solution architects in the room. In fact, we haven't called this out yet, but before we go to another break, anybody in Cloudera who's got an SE or a solution architect or customer success role, do you mind putting your hand up just for a moment? Yes, hands in the air so people can see it really high up. Put them up. All right. So next break, when you want to know, wait, he said this, how is that possibly true? Go ask them, and they'll tell you. I'll tell you too if you want to come to me. So we're talking about making things more efficient. We have a payments processor. These are people handling the back end of financial transactions. It is a large business which you would immediately know and call and say, Nick doesn't have rights to use their name, so I'm not using their name. But they were looking at what was going on in their environment, trying to, again, look for fraud, but they were limited to 1 year. Some fraud take years to unwind. The data that was lost this year in the big credit agency breach is going to be out there forever. They were spending more than $1 billion on their data warehouse to try to do this, and yet they could only look back 1 year, and it was kind of slow when they wanted to look in a different way. And fraud should be playing and testing different theories. So they moved ETL, exploration, other analytics to Cloudera. They got more flexibility, more scale, better histories of data. They were able to actually deliver new services to all the merchants that processed their credit transactions through them and say, hey, we can give you insight how the people are using this. Results, $30 million in annual savings, 1/15 the cost of it per terabyte. So it's not just about cost savings. It's about being able to do more, look at more data, apply different techniques, do machine learning against it. But cost savings is a great way to fund this. If you're a fixed budget or possibly decreasing budget, trying to figure out how can I deliver better services with the same budget I have, this kind of becomes a no-brainer. And so oftentimes we see people starting with this type of use case and then finding all the other things Cloudera can do for them. All right, third topic. I got three things, which is Internet of Things. And I want to talk to this one for just a moment. This is, again, very near and dear to my heart. A little over 10 years ago, I was the third person at a startup in the UK, which was doing a smart homes and energy metering technology. So we had sensors that would go on doors and windows. We had motion sensors. We think of your security system like ADT. You probably have that, or Honeywell. But we were making it so that you could self-manage it, and it would send the data to the internet. You could use your cell phone to text it and say, anything going on in the house, turn on the alarm, turn off the alarm. You could use it to check energy, which appliances are drawing how much energy at what time of day. So this was IoT before there really was IoT. When I said you could text your house, it was because our phones didn't have apps on them yet. So all you could do is text. And sometimes people are using dumb phones where you had to hit the number 2 3 times to get the letter C. So we're a little too early in that. But this space of technology has gotten a lot further advanced, and it's allowing governments to do some cool new things by managing the physical world that's out there. So those of you that are running physical things in your environment, whether it's tracking trucks or planes through port, whether it's tracking buses or police cars around town and figuring out service schedules or where they're deployed and how they're being run, there's a lot of cool use cases in this area too. Some of the questions we're trying to solve is how do we lower asset downtime? If a bus is out of service, that's not delivering the services the citizens need, and we're losing revenue on that bus route. People aren't paying into it. It would be expensive to go have it towed. If we could do predictive maintenance there, that would be better. How do I get more efficiency out of my environment? How do I use the lighting, the heating better? Turn it off at night, turn it on when people are in the room. How do I get the bathroom to sing to you when you wash your hands? This is a very important problem we need to solve today. Sorry, I'm being a little funny with that last one, but scared me like crazy. I went in there this morning, I was like the only guy in there. I put my hands in, suddenly somebody's singing right behind me. I don't know what the citizen experience they were going for there was, but probably funnier when kids are in there. But that's similar. Like, how are people using your services when they are engaging with a physical thing in your environment? What is their experience? How do we make it better for them? And how do we change our operating models? Could we do different types of services based on usage patterns? So these are all kind of IoT type questions. And a little bit different. Traditionally, our data centers are on not sensor data, so they are data that is from logical transactions happening over the internet in my environment. Here we're actually looking at specific things, whether they're home sensors, vehicle sensors, whatever. How do we look at those and make them smarter? And they're really getting deployed in a lot of different ways. Some of the use cases I've already touched on: predictive maintenance, connected vehicles, telematics, smart cities, industrial IoT. My good friend Tiffany is in the audience. Say hi, Tiffany. Tiffany and I went to Kashiwanoha a few years ago, which in Japan is a smart city that's piloting out a lot of these technologies. She's with Hitachi. Say hi, Hitachi. And they did really cool examples of like how the apartment blocks, rather than have a blackout, could have a brownout, and they could decrease your AC when it was too hot so that you didn't run out of power consumption. They could affect when lights come on. They could do the energy monitoring and metering, which is where my startup technology eventually got sold to British Gas, by the way. And they were able to do smart monitoring of gas and metering. So different types of services there. And then other things: supply chain optimization, operations, quality assurance, predictive maintenance. These are all different use cases where you have a lot of data coming in streaming in real time. Different environments need to be able to work with it. Challenge is, because it's real world, it's not perfect. You might have things go out of range of cell phone signal, like this room, for example. You might have trucks out in the desert where you can't read from them. You might have an oil rig you're trying to monitor. It's usually time series. It may not be well organized. I was talking to a group that is doing fracking. There's some oil exploration in the state, I understand. Maybe some concerns around that. How do you monitor it? So problem is, if you know anything about the business, is like thousands of consultants that each deliver their own services there. They have their own environments. How do we try and normalize that data so we can understand it? Different structures, different schemas. Time value of this could be very sensitive. It's no good for me to look at where do I send my snow plows 2 weeks after the snow is melted. I need to do it in real time. And so providing that sensor data and understanding the context, understanding the history in which it operates, that's kind of the key here. Being able to look at the long-term patterns. So we have some technologies that go behind here. Kudu is one of them that does real-time data. So a lot of times people think of Hadoop as a data lake. I'm going to load it, and then someday later I'll go back and look at it. This is really a different use case where we need to respond in the moment. We want to be able to work across clouds because the real world is distributed, not a logical thing. It is a physical thing spread out over space and time. We need to work with that. And again, we want to link it into data science, being able to do machine learning against this data so I can learn what is a normal operating behavior and what starts to indicate a problem. I heard a great use case with Caterpillar, where they have big ships that go out to sea. They run the diesel engines. The diesel engines push the ship through the water. I was explaining this to my daughter the other day. Problem is they also get like animals growing on the outside, barnacles on the ships, and they're trying to figure out how often should they scrape the barnacles off the side of the ship. The ship is a very expensive resource to have sitting in dock. They were just guessing. Let's do it every 6 months. Take it out of service for 3 days, pay $100,000 to have it scraped. But by monitoring the performance of the engine and the conditions of the seas it was operating in, seeing it was normal, they were able to figure out when the barnacles were actually providing more friction and it would be cost effective to schedule a time to bring it in. Much smarter way to use that resource. And they're able to do that with machine learning, looking at all kinds of sensor data, how much vibration, how much heat, how much noise, how fast the engine's operating, its fuel consumption, all those types of things. So Navistar is another great example of that. They spoke recently at our conference in New York, our Strata Data conference. If you haven't been, I highly encourage you to get your organization to fund you to go there next year. It'd be a great time. They talked about how they manage 300,000 trucks, buses, heavy equipment out there and how they're doing service schedules on this. And I've hinted at this one a few times already, so I'll cut to the chase. Basically, they were able to not have trucks break down on the side of the road, but predict when they need service based on what batch it's in, what conditions it's operated, what part numbers are in it. And they were able to take their maintenance costs from sending another big truck out to tow this truck as whatever is in the back of it is delayed to let's do predictive maintenance and let's service it in advance at a planned time of our choosing. Reduce their costs from 12 to 15 cents per mile to 3 cents per mile. And we're able to integrate data from 13 different systems, each of which was providing its own sort of sensor information, combine it and learn what are the combined patterns that make sense there. Smart ports, I mentioned ports a few times here again, tracking what's going in and out of the port, what resources, tools we need. There's some heavy equipment. I used to live near Oakland. We see these big cranes. They're really cool to watch if you ever get to see them move. They're also very expensive. How do we make that environment run as optimally as possible? Put the people in the right place, put the tools in and out, move those boxes and all the physical goods we have. And yes, track the security of what's in them, track the risk of illicit cargo is being transported in there. Really great use case as well for IoT, combining real world data in all kinds of new ways, bringing the analytics, bringing different queries, different capabilities all together against it in one place. So I touched on a few. Amy talked about how we're sending people to Mars and bringing them back home, and some of the logistics and latencies in there are kind of interesting. When you think, 100 milliseconds latency on a network here seems really, really slow to us. 15 milliseconds is more common. We're going to have like minutes, hours, or days of latency once we're going to Mars. How do we manage in that environment? All kinds of new things. Healthcare. I didn't go into this one at all, but as people are using Fitbits or Apple Watches or iPhone tools or other types of things, how do we use that to monitor patient health? Does that help us deliver services to people about their medical needs much more efficiently? Maybe we can do it even remotely. Rather than having come into the doctor and once a year take their pulse and weigh them, we can find out per hour all day long what's happening to them and monitor them much more efficiently. Be able to deliver much better services there, be able to do insurance more effectively, et cetera. So I think I went through quite a bit there. Hopefully I was somewhere near time. I was getting nice little flags on time from the back, and I think I covered it. But I'm sure there's more questions on how does the technology work, what are the details, how would I even begin to adopt that in my environment? We're just trying to keep the lights on here, people. These are probably very common questions. Again, lots of technical people in the room. One more time, if you're a Cloudera, you're an SE, Solutions Architect, Customer Success Manager, please put your hand up high in the air. I want everybody to see you. I'm picking on you because I want you guys to go ask them questions and get more detailed answers. So thank you. You've been a lovely audience. Tip your waitress on the way out. I really appreciate you listening. Thank you.